And I know when people ask me that, it's so, the stuff they do is so strange sometimes. So quadratic equation, ax squared plus bx plus c. So sometimes a is 1, right, in which we wouldn't see it. We would just have an x squared. B could be a 0. It could be missing that middle term. And c as well, you could be missing that. So if we were to draw just the graph of x squared, nothing done to it, b and c are 0, it's what we call a parabola. This point is called the vertex. So with a straight line, when we graph a straight line, we need 2 points and we connect them. Put arrows on the end and that's a straight line. With a parabola, we still need 2 points only. But one of them has to be the vertex. Right? You have to know where the bottom of that U shape is. Right? And then one other point, and that connects it. Because if we knew this point right here, why is that enough to draw a parabola? It's a function that we call even. It's the same on both sides. So say we knew this point was the point 2, 4, then what's the same point on the other side? So if this is 2 and then up 4, then this one is over 2 and up 4, so negative 2, 4. You sort of want 3 points, one on each side, but you only need the vertex and one other point. Just be careful you don't join them like a straight line. So how do you know it's not a straight line? Because you see the x squared. So you know if you see an x squared, the graph looks like this. It just could be moved around somewhere else. So we're just going to jump right in and graph these. I'm going to show you how to do that. So to find the vertex, there's lots of ways to find the vertex. This is the one way we're going to use. X equals minus b over 2a. Now, is this a new formula to memorize? It's actually not. Do you know the quadratic equation? The quadratic equation where is this on the quadratic equation? Look at the two and compare them. Where do you see that? The minus b is here and the 2a is here. So what's missing from the vertex formula and this? Just take that whole square root out and you've got the formula for the vertex. That's it. So if you know the quadratic equation, forget this square root part. You put minus b over 2a and that gives you the vertex, or the x value of the vertex. So that just gives you the x value. So then you plug in the x value into the original equation and solve for y, and that will give you your y value. And then you have a point that you plot as your vertex. And what about the other points? We really only need one, but you're usually asked for the intercepts. So we need to find the vertex. That's step 1. And step 2 is the x and y intercepts. No, never mind that. We don't even care. I'm not even adding an if. Let's keep it simple. How do we find the x-intercepts? Plug in y equals 0. The y-intercepts, plug in x equals 0. So the x-intercepts, we're going to let y equal 0, and then solve for x by factoring or quadratic equation. The y-intercept, let x equal 0 and solve for y. That one's the easy one. There's no factoring or anything. So 1, 2, 3 steps, you plot the points, you draw the graph, you remember which one's the vertex because that's the bottom of your U. And that's what we'll practice. So we're just going to do a bunch today with all different sort of things happening in them. Okay, number 1. So say we want to graph this, find the vertex, the intercepts, and graph. So the vertex first. X equals minus b over 2a. So what is b? Minus 4. Be careful. Okay, those are A, B, and C. A is 1, B is minus 4, and C is 3. We don't need C for the vertex. So minus B minus a minus 4 over 2 times A. So we get X is 2. Now that's not a point yet, but it's part of the vertex. How do we find the Y value? Plug it in. So y equals x squared minus 4x plus 3. Plug in the 2. So 4 minus 8 plus 3, negative 1. Okay, so there it is. Now the x and y intercepts is nothing new. We already did a whole section on that, factoring, solving the equation. So nothing new for, actually the whole rest of the chapter, all the intercepts are just going back to everything we did in chapter 1. Because when we do absolute values, we're solving an equation with an absolute value in it to find the intercepts. When we do all of the graphs, there's fractions that we'll graph, and that's the same thing. We go back to fraction solving. Okay, so x-intercept, that's the hard one. Let y equals 0. It's not that it's hard, but it's the one that we have to factor. So first question, does it factor? Or you can always just jump to the quadratic equation. I don't care, right? But 3 and 1. And we wanted to add to minus 4. If they're both minus, they multiply to be a positive, and they add to give a negative 4. So x equals 3, x equals 1. What are the y values for these points? Do we have to plug them back in to find y? They're 0. We already said what y was. Y is 0. The only time you have to plug them back in is when we do the vertex. These ones, the y is 0. So we've got 2 points, 3, 0, and 1, 0. So those are our two x-intercepts. Now our y-intercept. This is the easy one. You let x equal 0. So y equals 0 squared minus 4 times 0 plus 3. X is 0, y is 3. So we have overkill on the points because you only needed the vertex plus 1 to actually draw it. And why do I tell you that? In this class I'm asking for the intercepts. You have to find all of them. But in calculus, if you know the vertex and 1 point, you can draw a quick sketch, because what you're doing in calculus with it is you're going to use it for something else, and you just really need a quick sketch of it, sort of in the right place. So you don't really need the exact intercepts. So in calculus, you need the vertex and 1 other point, and then you just draw your parabola in. Okay? Here, we're going to find them all the important points. So our vertex, we'll put that one in first. 1, 2, and negative 1. 1, 0, and 3, 0. You see they're evenly spaced on either side of the vertex? They always will be. And if they're not, you messed up. Either the vertex or those points. They have to be evenly spaced, your two intercepts, because your vertex is in the middle of them. And then 0, 3. I'm going to draw this. So I know in high school you do like axis of symmetry, all these crazy things, but like I said, we're not doing any of that. This is it. If you draw the parabola, get the intercepts and the vertex, you're good. That's all you need to go further in math. Okay, so let's draw a second one. So each of my examples are going to be something slightly different in them. Okay, step 1, vertex, x-intercept, y-intercept. So vertex. X equals minus b over 2a. So a is 1, b is minus 2. C I can write down, but we don't really need it unless you use the quadratic equation later. So minus b, minus the minus 2 over 2 times a. 1. That's not a point yet. You plug it in to find y. So 1 squared minus 2 times 1 plus 4. So I just plugged it in to the original equation, and I got 3. So 1, 3 is my point. Now what? X-intercept. We let y equal 0. So our point will be y 0. So 0 equals x squared minus 2x plus 4. Does it factor? Two numbers that multiply to give 4. 2 and 2, will they add to give 2? No. Or subtract to give 0. What else? 1 and 4 will give us either a 3 or a 5? No. So what do we do? Doesn't factor, so... Right. Okay, so x equals so minus b, minus the minus 2, plus 2, b squared, negative 2 squared, is 4, minus 4 times a times c. What happens? Four minus 16. It doesn't even matter what's in it. That's a negative. So no x-intercepts because it doesn't work. So how could a parabola not have x-intercepts? Yeah. If it was up here, see it doesn't cross the x-axis? So half of the time you'll find no x-intercepts if they're above, and if they're below, you would find the x-intercepts, right? So no x-intercepts. So the next would be the y-intercept. Let x equal 0. Will this ever be none? Never. There's always, with a parabola, always it's going to cross that y-axis. Always. So you'll always find that as your second point. So y equals x squared minus 2x plus 4, because we can plug 0 into this equation, and it will always work. Basically, whatever's at the end. So x is 0, y is 4. So that's all we need, the vertex and another point. So sometimes we'll have overkill and have 3 extra points, or sometimes we'll just have the y-intercept, but we'll always have the y-intercept. So we draw it. We need our vertex is 1, 3. One, 2, 3, 4. So 1, 3. And this point is 0, 4. But remember, don't draw a straight line. This is your vertex. So it's going to be a U. And that goes through this point. And then what would be a point over here if you wanted to connect it to something? So we know this one. So here's, if you wanted to put that point on the other side, so you can draw it when you draw that side up, where would it be? 4. Right. Remember, it's the same distance from the middle. So it would be 2, and always the same height. So you can always get that other point. It's sort of the mirror image on the other side. So this would be 0, and then that's 1 away. So 1 on the other side is 2. But you don't need that to draw it. But sometimes when you're graphing, like if you're using graph paper or something, you'll want it to be even. So you don't need to really find it. But if it looks even, you're good. What I look for is that you drew a parabola, that the bottom of that V is at the vertex, or the bottom of the U is at the vertex. It has to be rounded, so don't make it a V. Don't make it pointy at the bottom. You will lose marks for that. And that it's even on both sides, and you have the intercepts. So I basically look at the shape and say, yep, there's the 2 points. That's right. What's that? No. So the question is, do we have to label it? And the only time you really need to label is when you draw more than one graph together. So here we're not going to draw more than one graph on the same graph, only straight lines. In calculus you will do that, and so my advice for when you get to that, when you have to draw, say, 2 parabolas on the same graph, is label them, because when you go back and have to plug points in, you look at your picture and you want to know quickly which one's which. So anytime you draw more than one graph together, you should label them. And that's really just to help you make it easier. Okay, what about this one? So what's different about this one? The C, or the constant at the end, is missing. Okay, so, and that's okay. As long as there's an x squared, it's a parabola. If A was missing, it would be a linear equation, back to the sections we just did. All right, so A is never missing here, because it wouldn't be a parabola. So vertex. X equals minus B over 2A. A is 2, B is negative 8, and C, in case we use quadratic equation, 0, because it's missing. So X equals minus a minus 8 plus 8 over 2 times A. So 2. Could these answers be fractions? Absolutely. Right? We want to keep it easy, but you can get a fraction, and then you'd have to plug the fraction into the equation. So it's a little longer, but it's still the same process. So now find y. 2x squared minus 8x. So we're going to plug a 2 in there. So 2 times 4, 8 minus 16. x-intercept. How do we factor this type when the c is missing? You do a common factor, that's right. So a common factor, so we take the 2x out, and we'd have x minus, take the x out, so that's gone 4. And then these are our two factors. So 2x equals 0 gives me x is 0, and x minus 4 equals 0 gives me x is 4. When it's a common factor, be careful you don't miss the 0. People do all the time. They just ignore that part because it doesn't look the same. But it's still, if x is 0, this whole thing will be 0. So what are our two x-intercepts? Remember, y is 0. So 0, 0, and 4, 0. And then what about our y-intercept? You're going to let x equal 0. Zero minus 0. We already had it, right? The x-intercept is where y equals 0, and the y-intercept is where x equals 0, and that point was there. So 0, 0 is both an x and a y-intercept. It goes through both axes. Okay, now let's draw it. So we have to go, the vertex is minus 8, so I need to go down at least 8, so that's a little lower. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's a good illustration, is that, look at the spacing of my tick marks. I made them bigger for x and smaller for the y, and that's okay. If one of them's 100 and one of them's 2, if you made the spacing the same for each, you're not even going to see your graph. Okay, what I'm saying is, if this was 100 and you actually wrote 100 tick marks, which you don't need to do, you could go by 50s if you wanted, and then this was 2, try to draw that graph. There's a parabola squished in there, right? So you have to change the scale sometimes. You want them to be not equally spaced. You want them to be spaced out enough that you can see your graph. So I said the vertex is 2, negative 8. So here it is. And then the intercepts are 0, 0, and 4, 0, which are 2 on this side of the 2 and 2 on that side of the 2, although mine doesn't look very even right now. I'm going to move my point. So this is rounded, and the very lowest point is at your vertex. I moved my point over a little so it looked a little bit more symmetric. Okay, so sometimes I'll draw the parabola in and then put the points in the tick marks so that it looks even. So I'll put the vertex, draw the graph, and then actually write the points in so that it looks right, because I'm not actually going to count your tick marks. All right, so you put this down, you draw your parabola, and then you can write your points in so that it actually goes through. Questions? Okay, so we saw 3 so far, all with something different. So what was the first one? The first one, we found the vertex and then the x, y intercepts, and it factored. The second one, we found the vertex and the x and y intercepts didn't exist. It didn't factor, and the quadratic equation failed. And the third one was missing a c. So that one, whenever it's missing a C, can we generalize that? Can we say something about this graph, do you think? What do you think always happens when it's missing a C? It goes through 0, 0. Okay, so that's always going to happen.
Unless you add, particularly for the x-intercepts, can we always just assume there's going to be that y?
Oh, for sure.
And
Yeah.
not have to worry about it.
Yeah. Yeah. Yeah, if you plot the vertex and the y-intercept, you can kind of guess where the x goes through when you draw it anyway. Right. Okay, that was number 3. Okay, so what about this one? What do you think? So do you remember from high school what happens when the A is negative? Right, it goes upside down. You don't need to know that because you draw your vertex and your points, and the points are going to be underneath. The vertex is going to be higher than your points. So you don't even really need to know that. But it's good to know that it's going to open downwards. So how we deal with this is no different for the vertex. So A is -1, B is 2, and C is 3. So for our vertex, minus B over 2 times A. One. And then what do we do with it? Plug it in. But be really careful when you plug this in because people make a mistake with this all the time. With that negative is in front of the x squared. You square it and then change the sign. That negative is not squared. It's in front of the x squared. So when you put this 1 in, if that had been a negative number, sometimes people mess up, and sometimes still. This is 1 squared with a negative in front. So the point is 1, 4 is our vertex. So for our x-intercepts, so think back to when we solved these equations, when there was a negative in front of the x squared, what did I say to do? Factor it out or change the sides so it's positive. So I would change all the signs, or you can move it all to the other side. So we get x squared minus 2x minus 3 equals 0. So when you're going to factor, so we did this before, whenever there's a negative in front of that x squared, you make it positive first and then try to factor. But by making it positive, you have to change all the signs, so be careful of that. You could use the quadratic equation and just use A, B, and C like they are. Okay, that also works. Or change all the signs. Does this factor? Yeah. 3 and 1. -3 plus 1. So 3, 0, remember y is 0, and -1, 0. Y-intercepts, or intercept, there's only be one. Put the 0 in, -0 plus 2 times 0. And again, that's just always the C, whatever the C is, because everything else will disappear that has an x in it. So x is 0, and y is 3. All right, so can we see all the points? Yeah. So, to graph it, we need to go up to 4. So 1, 4 is your vertex. Always put your vertex first. All right, so we know it's going to be a parabola going like that. Right now, we already know it goes that opens down, even if you didn't know about that negative in front, because if we found intercepts and the vertex is above them, how is it going to connect? If that vertex is above the x-axis like that, there would normally, if you had a normal parabola, not be any x-intercepts because it wouldn't be able to cross. Okay, so 3, 0, 1, 2, 3, and negative 1, 0, and 0, 3. Questions? Could you find other points on this parabola? Because remember, an equation is just infinite points that when you plot them, it looks like this graph. So how would you find the other points if you wanted to find like 10 points on this graph? How would you find them? Like if we wanted to know what this point is down here, how would we find that? You could, but that makes it harder. So she asked if can you make y equal to something other than 0. That would make it harder. Put the x in. So if we wanted to know, say here, where x is 4, remember doing table of values? You can do a table of values and find as many points as you want, right? So you can always plug in numbers. So if we plugged in 4, for instance, we get negative 16 plus 8 plus 3. Negative 8 plus 3 is negative 5. So this point at 4 is negative 5. And then the mirror image one over here would also, we could also get that, would be 1 less than this. So negative 2 and negative 5 would be over here. If you plugged in negative 2, you'd get negative 5. But you could go on forever and find all the, not all the points, but a lot of the points on the graph. So you can always do a table of value. Anytime you're graphing anything, you can do a table of value. Plug in x, find y. Plug in x, find y. We just don't need all those extra points. That was number 4. So 5. Oops. So here I put A is not just a 1, so I put a 2 in front. The numbers are just bigger, but we'll see what's different when we do it. So when we have, did we do one with the number in front yet? We did. So the number in front of the x squared sort of tells a bit about the shape, but you don't need to know that because the points are going to hold all the information you need. Does anyone remember what putting a number in front of the x squared does to the parabola? Yeah, like narrow or wider. I call it narrow because it makes it, the points go up twice as fast, so it's skinnier. It kind of pulls them up by 2, the 2 ends. Like the vertex stays, and if you grab the 2 ends and doubled all the points. So it makes it skinnier. Do you need to know that? No. Because when you draw the points, it's going to be skinnier. Right? If you find the right points, you put it on, it's skinnier. So you don't need to know that that's what happened. It's good to have some knowledge behind it. When you look at it, you say, well, it's going to be skinnier than a normal parabola. That if I didn't have the 2, it would be wider. And by putting the 2, it would be narrower. But you don't need to do anything with that information because the points will tell where it is. Okay, so vertex. So minus b over 2a. Negative 3. And plug that in to find your y. This happens sometimes. The numbers are big. Oh, excellent. I heard someone say you should divide it by 2. And that would actually give you the wrong answer, so I'm glad someone said it. But I showed you this in the first class, if not the second class of the whole year, what you do when you're plugging in numbers and the numbers are big and you don't like them. Does anyone remember? The easiest way to deal with it, the 2 does come out, but you can't divide it by 2 because then you're, what do you do with the 2? Bring it outside. So if we brought it outside before we started, then we plug our negative 3 in. We can just multiply the answer by 2 after, and the numbers are smaller as we go through. So if they do have a common factor, you can factor it out and then solve, and that'll make things easier. Or you could just go through and get your answer here. Negative 3 squared is 9. That negative's inside the squared. How come? It's x is negative 3, and we're squaring x. Whereas before in the last question there was a negative outside of the x squared, there's not here. So that's 9 minus 3 times 6. What's 9 plus 9? 18. So what do we get here? 0. 2 times 0 is 0. So y is 0, and that's okay. Because is not negative 3, 0 a point on the graph that we could draw? Right? So the vertex just happens to be at 0. So what about the x-intercepts? So x squared is positive, so that's good. So we either factor or use the quadratic equation. You might just choose the quadratic equation, or you might notice that a 2 factors out. So if we factor out the 2, does this factor? 2 numbers that multiply to give 9. 3 and 3, they add to give 6. So what does this mean? Is that 2 different points? No, you draw them right on top of each other if you wanted to, but it's not 2 different points. It's just 1 point, negative 3, 0. But wait. It's not even a different point. And doesn't it make sense that if 0 is the y, that's the x-intercept? Any point that 0 is the y is an x-intercept. So we already had the x-intercept. We didn't need to find it again. But there it is. And it's only 1. How can a graph only go through the x-axis once? Remember, it's a parabola. Wouldn't it cross twice? Right. The vertex is touching the x, so that's where it goes through, and then it either goes up or down from there. Y-intercept? That'll give us the second point. 0, 18. That's pretty high, so. I'll go up by 6s. And -3. Again, the scale doesn't have to be the same. Okay, it just has to be spaced out enough that you can see all the parts. So -3 zeros here, this is our vertex. And then the other point is here. Now because I changed the scale, this parabola does not look skinnier, but is it skinnier than normal? Yeah, if I drew 18 marks here, and 3 the same, it goes through up here and here, if I drew them with the same scale, right? I spread it out so that it would be easier to draw. And you probably wouldn't do that, draw 18 marks going up. But if you measured them the same scale, like these are the same width as these pieces, then it would definitely be skinnier. All right, we've got two last ones for this section, but they're both short. And then the whole section's done. What's missing? The B. Any ideas? This one is so easy you don't even need to do anything except draw it. I'm going to jump right to the graph. So our regular graph of an x squared is like this. Adding or subtracting a number just to x squared and nothing else changes, what does it do? What does adding 1 do? Moves it up 1. So here it is. Whoops, my hand got a little shaky there. So what's our vertex? 0, 1. If you went through and did it, minus b over 2a. b is 0 over 2 times 1 is 0 over 2, which is 0. And then if you plug in your 0, you get a vertex 0, 1. Right? So that's if we went through and did it. What about the x-intercept? How do you solve that? No solution, because when the b is missing, it either has to be minus and it's a difference of squares, or it's a plus and it doesn't work. So this one has no solution. And we just remember that x squared plus a number has no solution. Y-intercept, we already have it, where x is 0. Oops, 1. So nothing to do. X squared plus a number is so easy to graph. You just move it up that much.
We don't have to worry about...
I don't even worry about how wide it is, but notice I didn't put any tick marks to show.
So if we had a question like that one,
That's
we
it.
would literally just have to do the
It's
graph.
really, yeah. Let's say find the x and y intercepts, but you've already got them, right? Yeah. Now, what if you did want a second point? Remember I said table of values? You can plug in any number. So if you did want a second point, you could plug in, say, 2 to x squared plus 1. So 2 squared plus 1 is 5. So here would be a 0.25 if you wanted. Right? But you don't even need it. If you know the vertex and it just moved up, then there's no x-intercepts. Now, what if it moves down? Let's put -4. So sort of the same thing, except what happens if it moves down? So if this moves down 4, it does cut through but it's easy to find those. The x-intercept, let y equal 0. And how do we factor that? Difference of squares. So x plus 2, x minus 2. So what are these? Minus 2 and plus 2. So those two graphs are the really easy ones. But what we did was saw just about everything. The only thing I avoided doing was making the vertex have a fraction. It's no different. You just have to plug the fraction into a common denominator to find your y value. So it's a little harder, but there'll be some of those, I'm sure, on your homework to try. I might email people to do that. Oh, shoot. No.
No, I'm sorry. I